So today I'm going to be talking about business analytics and data science opportunities for Ukraine and for the world. And first, a very short introduction about IBM and what is to be an IBMer. So through the more than 100 years, IBM was always pioneering in science, now data science, analytics. And if you look at this slide, so what do we have? We have a number of inventions that were done by IBM throughout this year. So the first one is, as you see, 1969 is the IBM actually provided all the equipment for their data center, for the space center in Houston to launch a first person on the moon. 1973, IBM developed the barcode that now you can see on every product that you are buying in stores. 1981, IBM PC, personal computer, and actually now most people think that the era of the personal computers is ending or has ended, and we're entering the era of mobile devices. 2008, IBM started a program which is known as Smarter Planet, and that's really related to analytics. There have been quite a number of things related to other discoveries done by IBM, for instance, floppy drives and hard drives. And actually, one prominent IBMer, Romanko, who really is known to be the father of the hard drive. So because they developed that technology in the 70s at IBM, has Ukrainian background and has been here in KPI as well. So analytics and data science are among the best jobs that are currently really the hot jobs on the market. And if you look at the number of publications in different newspapers and media, Forbes, Harvard Business Review, for instance, Harvard Business Review called data scientist the sexiest job of the 21st century. And I would really agree with that. Of course, data science, analytics, and actually I'm going to use these terms interchangeably. Data science, analytics, business analytics, operations, research, mathematical modeling, because those concepts are really related to each other, and in many cases there is no need to differentiate between those. So data science is a multidisciplinary field, and it involves statistics, artificial intelligence, data mining, machine learning, visualizations, and a number of other techniques and algorithms that are really used to analyze and process data. So we'll start from trying to understand what is really business analytics, and after looking at a number of examples of both the analytics applications and the types of algorithms that are used to analyze the data. So I don't really have many formulas in my presentation, so only one formula that I will probably not even explain, but at least we need to start with a definition of analytics. And if you look at the definition of analytics, so it says that it's a scientific process of deriving insights from the data in order to make decisions. So what do? We get the data, we analyze it, we get insights, and after that we make decisions based on those insights and implement those into actions, into the practical actions. So analytics can be subdivided into three probably pillars, I would say it. So the easiest one and the most common one is descriptive analytics, which is answering the question, what has happened in the past? For instance, you may want to look what were the sales of your company in 2014. And this descriptive analytics is also known as business intelligence. In many cases, many people think about it as statistics. Second pillar is predictive analytics, which answers the question, what will happen in the future? For instance, we would like to build a trend for the sales of the product of our company in 2015. So that's what predictive analytics is doing, and usually such algorithms as data mining are included into the predictive analytics. And the most advanced pillar is the prescriptive analytics, which answers the question, what should we do? So what should we do to increase the sales of our product this year? And the algorithms that go there usually include optimization, artificial intelligence, cognitive computing, really advanced types of analytics. So why do we need to do the analytics? And in order to illustrate that, I am usually using the two slides. So this first slide, which looks really quite complex, but what it really shows, it shows the worldwide GDP in 2008. So the worldwide GDP in 2008 was $54 trillion. And of course, we can divide it into different areas like infrastructure, 12.5 trillion, finance, food, healthcare, and so on. But what's really interesting is the graph on the next slide, is that in that system of systems, in that worldwide GDP, there are 15 trillion of inefficiencies. Now, I'll explain in a second what are those inefficiencies, but what's even more interesting, that there is an improvement potential of at least 4 trillion or 7–8%. So we can eliminate 7 and 8% of those inefficiencies with the help of analytics. And in order to understand what are those inefficiencies, let's look at the graph. So what we have here in the horizontal scale is the inefficiency as a percent of the total economic value. So if you look here at the inefficiencies in the healthcare industry, there are 42% of inefficiencies. So what are those in the healthcare industry? Wrong diagnosis or incorrect treatment. So that's really, if we can really eliminate those inefficiencies, if we can make the diagnostics better, if we can make the treatment plan better, we are, of course, saving lives of people, and in addition, of course, we are saving money of the taxpayers. So there are 42% of inefficiencies in the healthcare, and on the vertical scale, we see which percent of those inefficiencies in healthcare we can eliminate, and the number here is 34% of the inefficiencies in the healthcare can be eliminated with the help of analytics. The history of analytics is quite interesting. I'll slightly zoom in into these infographics, because that's what in many cases is getting underestimated, how much of analytics was done through the years. And the history of analytics, of course, dates probably even much earlier than the Second World War, but most people think that the Second World War is really the time when the analytics was born. And at that time, at the top, you can see which algorithms were developed: Monte Carlo simulations, linear optimization, neural networks. And at that time, of course, analytics was mostly developed and consumed by the government agencies. A number of interesting projects that were done at that time. During the war, of course, many of us heard about the Enigma project, which was conducted by Alan Turing and his team in the UK, of breaking the Enigma code, breaking the German Enigma code, and I will mention it one more time later in this presentation. And 1944 Manhattan Project. So how many of you heard about the Manhattan Project? Just raise your hand. Yeah, so most of us know that the Manhattan Project was the project of the United States government to build a nuclear bomb. But in order to model the nuclear reaction at that time, so they developed the technique which we now know as Monte Carlo simulation. In order to simulate and compute the interactions of the particles, they had to develop this algorithm, which is now used in many other areas. And I'll talk more about simulation modeling a bit later. After the Second World War, analytics started to propagate into the corporations and large research institutions. So nonlinear optimization heuristic algorithms were developed. For instance, in 1956, a very well-known algorithm, which is known as the shortest path problem, or Dijkstra algorithm, was developed, and now it's used pretty much in all GPS devices to calculate the Google Maps, to calculate the shortest distance between 2 points. In the 70s and 90s, analytics goes mainstream and started using by their mid-sized businesses and technical startups. For instance, if you look at such companies as Amazon and eBay, so they started to develop the personalized shopping experience with the help of analytics. For instance, in addition to that, eBay was very interested and still interested in the optimal design of auctions, because the idea is to get as much money out of the options. So you want to design an option in a way to get as much money for, in this case, for eBay as you can. Google, at the end of 90s, developed their famous algorithm for ranking the web pages, and that algorithm is known as a page rank, and that's a big analytical problem, because what you want to calculate the importance of each of the websites in order to rank those in the search results. And for that, because there are billions of the websites, you are solving a large, sparse, essentially, problem. And the importance of the website, according to the Google, was defined. So your website is important if it has links to other important websites, and if other important websites have links to your website. And because of this interrelation, that's, as I said, is a large computational problems. Starting from 2000s, essentially analytics started to be used by small companies and analytics experts, and we see many new ideas like big data arrives. We also see advances in NLP, natural language processing, artificial intelligence, and so on. And what's next? So people think that in the future, in the next 5 to 10 years, according to my estimates, analytics will be used by everyone pretty much. And we are entering the era of personal analytics. And we're already there. So if you look at how many of us wear these wearable devices that at this moment really calculates the number of steps that we walked or the number of kilometers that we have run. But what we are starting to see personal recommendations based on that type of data. So how much we should exercise every day, what should we eat, when we should exercise, and so on. And it will just grow more and more personal analytics. So we'll be getting personalized advices about anything, career choices, whether to enter a university or look for a new job, or how to really estimate risk when you are buying a house or an apartment or looking to rent a new apartment. All those recommendations are starting to appear, and I think that's really a hot area for you to enter, to start your own startup. And I am really hope that out of this summer school, where hopefully a couple of startups will be born, or at least the ideas of those startups will be developed, because I hope that out of those 10 practical projects that you will develop in this summer school, at least a couple of those you would want to continue later on and eventually make a social impact, make money out of it, save lives. Let's look at the examples of business analytics. Movies. So the movie is really about the sports analytics, because what really happened, the baseball team, which is shown in this movie, was Brad Pitt was a general manager of Oakland A's, one of their baseball team in the US, who had a really small budget to buy players. So their budget was 4 or 5 times smaller than the budgets of the top teams. So what they have to do, they developed an algorithm that allows them to find the players that were undervalued by other teams. And essentially, they were able to buy those players which were undervalued and form a really, really good team that went into the playoffs, and I think won the playoffs one year. So now sports analytics is used everywhere, not only in baseball. If you look at hockey, football, other games, analytics is there. And second movie, which is very recently released, imitation game, is that what I mentioned already. That's about Alan Turing and his team, who were working in the UK during the Second World War to break the German Enigma code. And breaking the code, that movie is actually really about cryptoanalytics. And what it shows that, again, so you as a researcher, as an applied researcher, can make a large impact. And according to the estimates, what they did really broke the Enigma code and were able to read the German messages and react on those information in a smart way. So Germans were not able to figure out that their code was broken. And according to the movies, so it saved lives of up to 14 million people during the Second World War. So that information was classified at that time, and only, 50 years later, we learned that that's what's really happened, and that's what was one of the projects. And Alan Turing is a famous person, considered to be the father of theoretical computer science, famous Turing machine, and Turing Turing test, actually, which in the movie is called the imitation game, is the test that was used by the artificial intelligence people in order to determine how smart is the machine. So the test essentially was that a person sits in front of the terminal and communicates with somebody on the other end of the terminal and needs to figure out if that somebody at the other end of the terminal is a person or a machine. So if a machine can pretend to be a person and pass this Turing test, so that was considered to be the time when the artificial intelligence is born. It's still a lot of debate whether any of the existing computers has passed the Turing test, but that concept really was resonating with people, how we can build these links about the people and the machines, kind of the Terminator story. So analytics can be really easy. So analytics is not necessarily based on complex algorithms. So analytics may be very intuitive. So for instance, this example about the Formula One analytics, so there was no really computations. It was all learning from the practical experience. So what happened with the teams of the Formula One in the beginning of '80s is, before that, all the teams were using the hard tires for the Formula One races. And somebody noticed that if you put soft tires, so you can of course significantly increase the speeds of the Formula One cars and you can make the turns sharper and so on. But of course the soft tires wear much faster and you need to replace those from time to time. And that's what they started to do from the beginning of '80s. So they determined that even replacing the tires, you can still finish much faster. And now the time to replace the tires has reduced to 2 seconds only. In addition to that, they also noticed that if you don't put the full tank of fuel and just have like 1/3 or 1/4, the car can run much faster. So, but in that case, you need to refuel. And that's the type of analytics from experience that they learned. At that time, somebody noticed, and in 1 year, every team in the Formula One, starting from 1982, if I'm not mistaken, is using those procedures, replacing using soft tires and replacing those and refueling. So second possibility is you can just find novel uses for the existing algorithms. So you, as I said, first you can notice from experience and don't use any algorithms, or you can find novel uses for the existing algorithms, like the shortest path algorithm, which is known how to solve that problem efficiently for almost 50 years. But what Yahoo started doing recently, a year ago, they use the same shortest path to find the most beautiful path or the most emotionally pleasant path. So if you look at their screenshots that they provide, so in London, if you want to walk between two places, you can of course find the shortest part in terms of the distance or in terms of the walking time. But you can also find the shortest part, or not the kind of the shortest part in quotes, the most beautiful part around the city. And of course, in that case, you need to define your distance in terms of the beauty score and not in terms of the kilometers. So how we evaluate the beautiness? So you nice buildings, nice walks, and so on. So they can also calculate the most quiet part, so when you have a walk on the most quiet streets. Or they are able to calculate the happy part. I guess you are going from pub to pub and do this sort of pub hopping in order to probably, I'm not sure if you are able to reach the final destination if you follow the most happy part. Probably you get to sleep under one of the bushes in the middle of your route. Second, the third types of analytics algorithms are really developing the algorithms in addition to finding the novel uses. And what is making analytics possible in the recent years is the availability of data. Or really, we are able to collect data cheaply, store data cheaply, which was not even possible 10 years ago. Plus, all the social aspects. So if we look at this famous picture of their papal inaugurations in 2005 and 2013, we can notice that in only 8 years, the number of people who are using cameras on their cell phones, on their smartphones or tablets increased dramatically, like 100 times. And all those people are now posting those photos on the social media in real time. And what it allows us to do, it allows us to analyze what has happened in any part of the city. Like if an accident happens, people start taking photos, post those on Facebook, tweet about those, and you can just analyze that information almost in real time in order to really figure out what has happened and how to react. And this is very related to the smart city stream or the applied computer science stream. So the devices that provide that information, for instance, there are 30 billion of radio frequency ID tags, those small pieces with the barcodes that they put on your luggage in the airport to be able to trace it wirelessly on a distance, or put those on the boxes in a truck so that you don't need to unload the truck in order to figure out what's inside it. 1 billion of smartphones, 85% of new cars have their devices that record information, not only the video, but also information about temperatures, about the behavior of the outside cars, and so on. So we are getting a lot of social data, like in 60 seconds, there are 370,000 minutes of calls on Skype, or 700,000 search queries on Google, and so on. All this data can be harvested and used for analytics. And now we look at a couple of videos that really provide us with examples of analytics, and we just discuss what we see in those.
I used to think my job was all about arrests, chasing bad guys. Now I see my work differently. We analyze crime data, spot patterns, and figure out where to send patrols. It's helped some U.S. cities cut serious crime by 100%. By stopping it before it happens. Let's build a smarter planet.
So this is a quite common crime prevention analytics which is used by many police departments throughout North America and Europe. And that's, for instance, we developed it at IBM, and this is really related to spatial temporal analytics, spatial temporal algorithms. So what we do, we analyze the crime patterns in different parts of the city and are able to predict at this time what is the hotspots, what are those areas in the city where the crime will happen with the highest probability, and we're able to send patrols to those hotspots, to those high probability crime areas, and reduce the crimes. So, and that's all what can be done with the help of analytics. You don't need to hire new police officers, you don't need to buy new police cars. Essentially 20% reduction in the crime rate, as I mentioned here, in many cities that implemented the system, just investing in their software and analytics on the top of it. So second example is the marketing analytics. Yeah. Yes. The video doesn't start when I click.
My specialty is pastries, not predictions. Knowing what to make and when could help cut down on thousands of unsold baked goods per month. Using analytics, we discovered when it's drizzling outside, people eat more cake. And when the temperature rises, panini sales go up. Finding these hidden connections helped our European bakeries increase profitability by up to 20%. Let's build a smarter planet.
So this is the analytics based on pretty much analyzing their purchasing of their bakery goods in the bakeries based on the weather. So if the temperature rises, people buy one type of baked goods. If it's raining outside, another type. So if you just do this historical data analysis and after that are able to use the weather forecast for tomorrow, you can decide which goods to bake. And again, so 20% increase in profitability. So the last application that I will probably talk is the artificial intelligence, and in 2 slides we can see what is the difference between the search engines like Google and artificial intelligence systems such as IBM Watson. So if we type the sentence, in May 1998, Portugal celebrated the 400th anniversary of this explorer's arrival in India, into any search engine, so the search engine is doing the keyword matching. So the word celebrated would be matched by celebrated, May 1989 in May, Portugal, explorer Gary, so we may be able to find a sentence that in May Gary arrived in India after he celebrated his anniversary in Portugal, which has a completely different meaning from what we were searching for. So artificial intelligence system in contrast. So what is the artificial intelligence or cognitive computing system? It's a system that uses multiple algorithms in order to figure out the meaning of the text, of the sentence. So, for instance, so if you had dates and times in their sentence, so May 1989 and 400th anniversary, it will use the temporal reasoning algorithms to find out that this may correspond to the 27th May 1498. So if you have words like arrival in, so arrived can correspond to landed, flew, walked, and so on. So there are algorithms that are doing statistical paraphrasing in order to find out the equivalent syntactic constructions in the sentences. So for instance, it may find that arrived in is equivalent to landed in. If you had geographical objects like India, so it may use the spatial reasoning algorithm to find geographical objects in India like Kapat beach. And if an explorer is mentioned in the sentence, it will go through all known explorers and may find that this is Vasco da Gama. So as a result, the equivalent sentence that you will find is that on May 27th, 1989, Vasco da Gama landed in Kapat beach. So that's a difference between the cognitive computing and the search engines. And of course, the cognitive computing systems, they provide you a number of possible hypotheses ranked by probability of the real meaning of the sentence. And this is what IBM Watson computer is doing. That's a
An IBM computer system named Watson won Jeopardy. But the real winner? Humankind.
Life is really about questions and answers. This technology can help us get some of those answers.
We're going to revolutionize many, many fields with this new capability.
Healthcare, government, finance, anywhere decision-making depends on deeper understanding of the huge wealth of information that's out there.
I thought the game was the end. I'm realizing it's just the beginning. That's what I'm working on. I'm an IBMer.
So IBM Watson is probably the most known artificial intelligence system in the world at the moment. So, and it became known after the computer world, this Jeopardy game, which is known here in Ukraine as Svoya Igra. And after that, it's being used in healthcare, it's being used in finance. Like in healthcare, it helps doctors to develop their diagnoses and the treatment plans for the cancer patients, for instance. And it's all based on analyzing the textual information and making a decision based on it. So now we will look at the couple of their classes of algorithms that are used in analytics and data science, and we'll look at simulation modeling. So what is simulation modeling? Basically, simulation modeling is a random number generation. So all their Monte Carlo simulations or other simulation modeling are based on generating the random numbers. For instance, if we want to model the probability distribution, and that's usually the output of the simulation model. We want to find the probability distribution because the future is uncertain for some event. And in this case, for instance, we would like to estimate the distribution of the global mean temperature resulting from doubling CO2 emissions relative to the prehistorical value, based on generating 100,000 scenarios. So what we will essentially do, we'll look at all the factors that contribute to the temperature rising, like melting the ice and so on, and we will put those together by generating the random numbers, because we don't really know how much ice will be melted. So we'll be generating numbers, random numbers, describing how much ice will be melted in scenario 1, scenario 2, combine it with the other effects of the global warming and build this empirical distribution, which really tells us that the average temperature increase in that case will be between 1 and 7 degrees. And the worst 5%, in the worst 5% of the cases, the average temperature increase will be 4.7 degrees or more. And this is really something that is dangerous. So when the temperature increases by 5, 6, 7 degrees, of course it happens with a small probability, only 5%, but that's where we need to start to worry, because in that case the ice will be melting and we will see that many cities will disappear because of that. So we need to really take measures to prevent that. But before taking measures, we need to really get this probability distribution using simulation modeling. And here is one of the examples of the video that talks about one such system that we use for simulation, which is called the AnyLogic. So now what we can do do the simulation modeling with the help of different software packages, with doing visual stuff, so we can model for instance, the call center. We can model the railway station in order to increase the capacity of the railway station. We can model we can model a warehouse and decide, with the simulation one, decide what is the optimal placement of the goods inside the warehouse. We can model the delivery of different goods in rural areas. Moreover, we can model military operations, and all the military operations now are modeled with the simulation model, because you can simulate different scenarios of those military operations. And all this is done in an interactive manner. So here is a model of the rail, of the subway, of the metro station, and you can decide how you optimally place the tourniquets, booths, in order to increase the capacity, the number of passengers that can go through a station, especially in the peak times. The same, you can model urban dynamics, you can model a number of other things, you can do agricultural modeling. Simulation modeling is essentially the tool that allows us to evaluate the decisions. Like if you want to build a new production line in our plant, first we will use simulation modeling in order to find the bottlenecks, the breakage times, and so on before we really build it, because it's a cheap way, so we model it before we really implement it in practice. Second type of the second group of the algorithms is optimization. So for instance, in the road design problem, if we are given 2 points, points A and point B, and want to build a road between those 2 points, and we want this road to be the cheapest to build and maintain, so what we can do, we can build it this way, we can build it the other way. Probably it's not that much visible because the colors are dark, but really, we have a number of possibilities to have this horizontal alignment for the road. In addition to that, we can run optimization to really find how much of the vertical alignment for the road we can do and how much of the earthwork we can do. So what we see here, so here is our landscape, so that's a hill, that's a hole in the ground, and we want to build this road. So what we need to do, we really need to, in some parts of the road, we need to really excavate. In some part of the roads, we need to fill those holes with the soil. And of course, we can really break the road into a number of segments and find out how many cubic meters of the soil we need to either excavate or put back, like here in the holes, in order to have the road. For this, we can solve an optimization problem. That's the only equation that I have in this talk, so I'm not going to really explain it much. We have a presentation about optimization modeling, but what we are doing, we are minimizing the cost of constructing the road, and we have the constraints that really, so here we need to excavate 1 meter, here we need to fill 1 meter, and we can find out the optimal way to really build this road. Of course, on the top of that, we take some enhancements, so we're not necessarily building the road horizontal because it's not the cheapest way, so we may have these curves in the road as well. And that's all done in practice. So my colleagues, for instance, in Canada at University of British Columbia, Okanagan, working on this with their industrial partners. So if you talk about text analytics, so in the simplest case, and you will have tutorials and lectures about their NLP, about sentiment analysis, text analytics. So here, all what I'm talking is just the introduction. So the simplest text analytics is probably a sentiment analysis. And what people usually analyze for a sentiment are tweets. So if Starbucks, as a company, want to really find out what is the sentiment, positive, neutral, or negative, of their people about Starbucks. So what they do, they go and get the tweets with the hashtag Starbucks, using, for instance, Twitter API. And after that, what they do, they look for the bad words and for the good words in those tweets from the dictionary. So there is a dictionary of good words, there is a dictionary of the bad words, and we are trying to find these good and bad words. So for instance, here we found that 13% of the tweets is positive, like the good words are the best, pleasant, excellent, and so on, and around 4.3% of the tweets are negative. So the words are hate, want, bad, tired, and so on. So this is a simple sentiment analysis, and what we can do, and because my talk is called, so I'm talking about the possibilities in analytics in Ukraine and worldwide. So let's look at what sort of text analytics can be useful for Ukraine. So if you look at the number of articles published in New York Times that use the word Ukraine and plot this graph, through the years, we see that the number of articles published in Ukraine significantly increased in 2014 to like 14,000 from around, 500. So this is a significant increase. So what we can try to do, we can try to harvest all those articles, and some students of this summer school already worked on this problem during the 2-day course that we had prior to the summer school. And got some nice results. So we can try to harvest these articles and determine the sentiment of the articles about Ukraine. And actually, what was determined during those preliminary studies that we did during this 2-day course that we had this weekend about business analytics, that the sentiment in the New York Times articles are more negative than positive about Ukraine. So, and based on that, you can go and try to use a deeper text analytics to learn why the sentiment was more negative and what can be done to really change that. Second interesting project about the text analytics that, the project is really about collecting the data about the publications about Ukraine. And that project is called OKO, which run by 2 organizations, Razum for Ukraine in the US and what it's called, and by essentially the Ukraine Image Agency by Ruslan Olezhichko. So what we did, and the project, as I said, was started by Razum for Ukraine by Luba Shipovich, who is now coming as a CTO for the Odessa region, and I think you will have a chance to talk to her at this summer school in a couple of days. Yes, Dmitry. So she will be working in the team of Mikhail Saakashvili in Odessa and essentially trying to make the Odessa the IT information technology hub. So that's the project that she started, and it's they collect information about publications about Ukraine in different languages, Ukrainian, Russian, English, Arabic, French, Spanish, so on, and they publish information, that information online. For instance, this is the information for June 2015, like the number of publications about Ukraine in Canada was 191. And what we also do, we do a basic semi-automated, essentially, business intelligence about the topics that were covered in those publications every day or every week. So, and we can really see how many publications were about the war in Eastern Ukraine and so on. And if you look for the week of July 19 to 26, the hot topic was the new police in Kyiv. So I hope that all of you will have a chance to make a selfie with the new Ukrainian police while walking in the city, and probably we should invite them to make a selfie with all summer school participants. So that's how it's done. So what would be good to do, and for this summer school, next summer school, is to build analytics on the top of that information. Again, sentiment analysis, so in which countries there are publications about Ukraine are more negative, what can be done about those, how we can really approach the whole brand of Ukraine, and what can we do with the help of analytics. So there are many, many interesting issues that you can work on those. The third, probably the fourth class of algorithms are spatio-temporal analytics, which is really trying to, for instance, identify the hotspots. And hotspots are the areas in the cities where, for instance, there are many traffic crash incidents, many 911 calls, many crimes, and so on. So what they can do essentially, that's a clustering. That's a clustering. You want to cluster those hotspots, and we will be talking about data mining and clustering in this summer school. So as a result of that, so what we can run, for instance, one of the clustering algorithms, which is in this case is called DB-scan, and we can find the hotspots for the burglary incidents, for the robberies in the cities. And after that, so here is the hotspots for certain parameters of that algorithm. Here is for a second set of parameters, and here is the coverage is better. It covers 54% of the points versus 31% of the points, and that allows to find those hotspots, those clusters for the crimes, and try to analyze why in that part of the city the crimes happened at that geographic location and in that time period. That's why this analytic is called the spatial temporal analytics, because we are trying to analyze this dependence in space, like geographically, and in time, during the time periods. And we can look at how those hotspots has moved through time, through the years, and see why their crimes shifted to another area of the city. A second type of spatial temporal analytics is GPS trajectory analysis. So we can essentially build the heat maps of the trajectories. And the last example, what we can do. So for instance, here the crime has happened, and what we see the 3 routes of the police cars in the vicinity of the crime that the police traveled within the 30 minutes time from the crime. So what we can analyze, so why the crime was not really prevented, because the police cars traveled quite close to the crime location and within the short time. So, but we don't really know, and that's what we can try to determine with the help of analytics, why and how to prevent. So there are also spatial temporal analytics which is related to Ukraine, and a project that is, I think, is very important is called the Bellingcat, is the vehicle tracking project, which is done together with the Atlantic Council. If you don't know, Atlantic Council is a think tank of their well-known former politicians like John Herbst, former ambassador to Ukraine. And one of the things they do is they collect their photos of the Russian military equipment taken by people, and people are able to tweet those with the hashtag Putin at war, and as a result, what they can do, they can match. So the same military equipment was seen in Russia in those photos and in Ukraine in the photos. So they do this, for instance, if you look at this cannon that was first seen in Rostov on July 2014, and after it was seen in Novoazovsk near Mariupol in September of 2014. So that was pretty much, so this is the crowdsourcing or crowd-funded analytics, and that's really important to build analytics on the top of that to see how it progresses. So how we do this, so essentially if you look at these 2 photos of the same tank, what they do, they identify the features of the tank that looks the same, and after that we are able to match it. So far this process is mostly manual, but of course there are algorithms for image recognition that can help to automate this stuff. And now there are all these maps for the locations of these different military vehicles in eastern Ukraine. So another very, very interesting is tracking Russian soldiers in Ukraine, and this is really a cool investigation done by the Vice News journalist Jim Ostrovsky, which is called the Selfie Soldiers. So what he was doing, he was able to track Russian soldiers from Buryatia, so his name is Bato Dambaev, from his military base in Buryatia through the training camps in Russia to the eastern Ukraine and back. So what he was doing essentially, Bato was posting his photos on Vkontakte, and some of the photos even had the geolocation information, and the other photos, so Jim was finding exactly the same spots and making photos exactly the same spots. So when Bato was traveling from his military base in Buryatia to eastern Ukraine, he stopped in Moscow, Russia, so that's the photo. After that, he was in the training camp near Taganrog, and he was posing with his peers with a Russian uniform, in a Russian uniform with flags, so which identifies that they are part of the active Russian military. And Jim made the same photo, went to the same place, another place in Taganrog on a military military ship monument, and the photo in Volnehirsk, Ukraine, where the bateau is posing in front of the villages, and so Jim Ostrovsky was able to find exactly the same place and made exactly the same photo. And after that, this photo is made in Ulan-Ude, Buryatia, when the bateau returned from the mission in eastern Ukraine. And all of this was done pretty much using Vkontakte social networks. So all soldiers, they post photos, and you can do geolocation and match those photos to locations. So another place where Jim was, of course, not able to enter is a Russian military training camp near Ukrainian border, Kuzminsky camp. And if you look at the Google Maps of that camp, in October 2013, there was nothing there. So in October 2014, there are military vehicles and equipment, tents, and here was a photo of the bateau with this dog, and essentially many other people were posting their photos with the same dog and attributing those to the Kuzminsky military training camp in Russia near Ukrainian border. So this is, in addition to that, so in the last, 5-10 minutes of my talk, so there are also interesting stories about visual and video analytics that we can use. And this is a very classical example of the visual analytics done 150 years ago. That's a map that shows the Napoleon military trip to Russia in 1812, and what it shows quite a number of information pieces. So that's a map, that's a number of soldiers that Napoleon had when he left for Russia, like 400,000. After that, when he was in Moscow, his army reduced to just 100,000, and then he was retreating from Moscow, this black line. At the end, he had only 10,000 soldiers remaining. At the bottom, you also have the information about temperature, because when Napoleon was retreating from Moscow, the temperatures was cold, and here is the temperature that really contributed to the death of many French soldiers. So there are other simple visual analytics, like this really tells us that the sales of one product of Apple, which is iPhone, were exceeding, the revenue was exceeding the whole revenue of the Microsoft for all Microsoft products, and we can try to make conclusion based on that. So this is the graph that we do to enable portfolio modeling. So this animation allows us to see how our portfolio of more than 1,000 financial instruments changes when we use optimization to construct a hedge for it. And other video analytics allow us to identify the hotspots for when somebody was working on the platform, on the rail platform, so we can identify the hotspots where that person may have left something, so to prevent terrorist attacks. And this is another really connection to Ukraine. So this is a crowdsourcing analytics that was done based on a video that was posted by one of the amateurs from Donetsk, and that person was filming from his balcony, and he filmed the cannon firing. So essentially here in that video you can see that the cannon shell is flying through the city. And what they did, so to do this, so they measured this distance, so 300 meters, and the shell is visible on the 7 frames. So which means that the time we see the shell in this video is 7/30, a fraction of a second. 300 meters, so we can determine the speed of the shell, which was 1,500 meters per second. So what they have done next, they projected to the Google Maps. So they calculated, as I said, the speed of the shell. And after that, based on that, so they know the ending point of the shell, and they know the type of the shell. So they were able to look in the military tables the initial speed of the shell. So initial speed of that shell was 1,785 meters per second. At the point where it was filmed, the speed got reduced to 1,500 milliseconds, which corresponds to the 2.5 kilometers that, so essentially at the place where the shell was fired, it's 2.5 kilometers from that balcony, and they built this information, and they showed that it can. So this shell was not really fired by the Ukrainian military, because the Ukrainian military positions are 6 kilometers or more from that place. So that really shows that all these speculations, for at least for this shelling, it was not done by the Ukrainian military, and it was all done by the crowd sourcing, essentially. I'll skip their stuff about the big data, but big data is something that we can do analytics with, and my idea about the big data is that it's only useful if we can do analytics based on it, and due to the big data, we can, instead of doing the physical models of, for instance, this turbine, wind turbine, we can do the data-driven models and use only data from the sensors in order to do predictive maintenance for the turbines. And essentially, I had some literature, and we'll probably look at some of those books in the other courses that I would be teaching at this summer school. There are some sites where you can really educate yourself about the analytics and algorithms. And so I probably will just stop here and summarize what I just said. So in my opinion, so analytics, data science, mathematical modeling, operations research, whatever we call it, is really something that is going to be driving many of the important projects in all countries, including, of course, Ukraine. And it's time to capitalize on that in Ukraine. Essentially work on interesting projects, try to do a startup in analytics, try to find a job in analytics, and save lives of other people, improve something, and really try to make the difference in this world, because we are living in times when data and analytics on the top of it can make a huge difference, save resources, save people's lives, and it's time to jump on analytics. And I invite all of you during the summer school to choose a project that really suits your needs and do something important. For instance, an early warning for, so we can always try to find a correlation between the Russian military convoy entering the Ukraine and the number of shellings of the positions that are done. So that information is available, so we can do the early warning. So when the Russian convoy is entering Ukraine, so we can identify the hotspots for the shelling areas and have an early warning for the soldiers on the front lines, and of course for the civilians as well. So please join the movement, and thank you for your attention.
Thank you very much. I guess we have just a little bit of time for a few questions. So if somebody has a question, then please speak up, raise your hand, and I can give you a microphone so you can ask a question. Yep. Zhenya, I'm coming.
Hey, thanks for a great talk. So it seems that there is a massive use of unmanned vehicles that can just, well, take a huge amount of data by flying around and can be coordinated for whatsoever purposes. Is there anything that data mining can do there? So to use that kind of data collection?
Yes. So the simple answer is yes, and this, of course, image recognition and pattern recognition on the images is still a topic that is being developed, and there are some successes in certain image recognition areas, like face recognition is quite developed, but the recognition of their I don't know, military vehicles on their videos made from the drones is still something that requires a lot of attention, probably needs at this moment is mostly semi-manual. So you can probably identify the geographical objects that look like vehicles, but of course the videos from the drones can be low resolution and stuff like that, so you need to do a lot of image processing transformation, but that's something that should be done and is done, and we are really improving to really move to the automatic object detection in those images, and that's something that is done and should be done, yeah, in my opinion.
Cool, thanks. Anybody else? Any questions? Maybe participants? Yep, sure. Sorry, I thought that, yeah.
As I understood these simulations, you use some sort of idealization So you simulate certain parameters, right? You can't simulate all of them that could influence essentially, right? So in the train station simulation, you didn't include sort of what kind of weather is outside of the train station, which could sort of influence the flow of the passengers inside. So essentially you do some idealizations, but in the end you make some actions. So you want to sell the story, so you want to sell the simulation. So how can you claim that the simulation is going to work in the real world?
Essentially, the only technique that people rely on so far, can rely to a certain extent, is the backtesting. So you can test your model on the past data and try to predict the flow of people, in instance, in the train station when you run the simulation 1 year for 1 year ago, and you know the results. So after that, you compare your simulation results to the historical data, and you see how well your model matches what has happened. Of course, you need to take, in that case, you still need to take into account the possible growth in the number of passengers in the train station and the other uncertainties that, of course, we know that the history doesn't repeat itself exactly. So we cannot really assume that the history will be repeated by Y1 in the future. Even so, it's still a common assumption for many models in different areas like simulation and finance. So, and there is no single answer. So what we are essentially talking about the model error. So you may try to incorporate weather into your forecast, you may try to incorporate other parameters, but at the end, so the only way is to do the out-of-sample testing, and the historical testing is pretty much the easiest out of it. But otherwise, simulation is an art and a science, but so the must-have, always try to validate your model results by the historical data, because the famous saying by Dr. Cox is that all models are wrong, but some models are useful, and we have no better way to represent the reality than the models. And if we think that the models give us useful results, we should use those. But before using those, of course, we need to try to validate in a number of ways. Of course, there are many statistical methods like cross-validation, other things to do the validation, but at the end, it's all back to the probably historical data, because and trying to incorporate some changes to the history into our models that may not be really visible in the historical data.
Just a quick question. The brain appears to be one of the best modeling tools on this planet. It creates spatial models, temporal models, combines historical information, predicts what's to come. Isn't then analytics is just a part of computational neuroscience?
Is analytics part of the computational neuroscience? Well, that's, so there is always this debate about what's first, application or the algorithm, let's call it that way. So analytics or the application. So some people think, and I may be slightly misinterpreting your question, of course. So some people think that analytics is part of every science, like neuroscience, of, I don't know, smart cities, of any application area. Some people think that, and I would agree with the second approach, that analytics is like an umbrella that includes different algorithms, and of course you can apply those algorithms to applications from different fields, from different areas. At the end, in my opinion, what's enough to know by the data scientists, so it's enough to know you talk to a subject matter expert in that area if you are not an expert in that area, and you get the data, you clean the data, you validate it. After that, you, as a data scientist, should know which algorithm may be applicable to that problem and try those out and see the results and compare and decide which algorithm is useful and can be used, or if you're not finding any algorithm that is useful at the moment, you try to develop or try to improve one of the existing algorithms. But that's the whole story. So analytics is, I think, is everywhere, and we should take advantage of it. So I'm more proponent of the second approach, and I don't really think that the analytics is part of neuroscience or any other science. Analytics is used and should be used in all sciences, in all application areas, and every company should take advantage of it, every government, and we as individuals. And it's going, and we need to really promote analytics, talk about analytics, and convince our companies, our employers that there is a use there is advantage, and I can show you how to do it. We can try this out because there is nothing to lose, and see if we get any improvement. So the best is always to really show what the results of your analytics and compare to what was done before. And this is, and you may get many surprises. So just another 20 seconds for an example that is quite well known. So analytics is now used in hospitals, for instance, to really help doctors to decide whether a patient who arrives with certain conditions should be seen immediately and put in the hospital, or they can tell him or her to come in a day or in a week. And usually it was done by the doctors, but the analytics algorithms that are now used to that, so they are having a 20% more predictive power, like increase from 60% when it's done by the doctor to 80% by the done of the algorithms. But so there is no really intuition why the algorithms predicts better, because you're using data, just data, to find these hidden connections. And there is a lot of disbelief by the doctors how you can really replace a doctor with 20 years of experience by the algorithm, even so the algorithm results are proven to be better, and there is a lot of fights in that, and there is lots of disbelief. So we need to, of course, there are disadvantages that analytics can put people out of the jobs. But if we are able to save lives due to that, so that's life. So
thanks. Thank you, Sergey, for a tricky question. Brain is indeed the best model, the best generator of the models of them all. Thank you, guys. Let's thank again our plenary talker and plenary speaker.
Thank you.